In this video, you will be able to learn about the steps of primer designing, how to design a primer. It is consisting of 5 steps in total, and the primer that we will design, we will check it in the end that either it is correct to use for PCR or not. So moving forward to the first step, which is about sequence retrieval. How to retrieve the sequence? Simply just click on NCBI, write the name of your genus. You can write about this organism's name, Staphylococcus aureus, its species name, anything, strain name, whatever you want to, and if you even know about the gene ID, you can write it as well. So this is a sequence, FASTA sequence. The second step is about orientation. Run blast, click over here, run blast. The option is that you can paste this sequence in this blast site as well, like copying the sequence from the previous window and pasting it over here, and then just click on the blast. So both are the options, both are feasible to use. You can use any one of them. So as I have used this one, the first one, I clicked on it and run blast. Again the similar window will pop up. So it will take few seconds to give me the results. This step basically primarily gives you the orientation for the further step of alignment. Few seconds are remaining. So this is how the results will appear in a new window. You can see that all the options are selected. From this checkbox, unselect all the options, and the critical step is that you can see same is the organisms, but there are different strains, and now the point is which one to choose and which one not to choose. So how we will get to know that which organism should we select here for the alignment or which should not select? It will be described by the orientation. So how to describe the orientation? Select some of the boxes over here. You are supposed to select basically the sequence, and you will click on the checkbox. So here the alignment is given. If the strand is showing you plus plus, it means both the strands are in 5' to 3' direction. It means that this organism or the sequence of this organism is good for alignment, and we will select. So all you are supposed to do, if it shows plus plus, the second one as well, third one is also correct, and the fourth one is plus minus. Now what we will do is we will exclude this one sequence. So after excluding this sequence, what will you do? Now at least if you have 4 to 5 alignment sequences with your query, what will you do? You will download this file by clicking on FASTA aligned sequences. Keep in mind that all of your sequences must be in similar direction, which is known as the orientation, and the detail of this orientation will be in description box. That in this window you can see that there is a file. This is a file that we are going to use in next step of multiple sequence alignment. So this is the sequence. Here you will choose the file. Downloaded file will be in your download option. So this file has been chosen from here, and simply click on execute multiple alignment. As you can see, this file will be shown as this sort of. This is a horrific window that literally amazes you. You don't get any idea that what should we suppose or analyze from this window. First of all, you need to see that these sterics, you will observe these sterics. As these sterics are all conserved in the whole sequence, it means here we have 100% alignment. Now the step of grouping is not necessary. You are not supposed to select from here or there. You can select from anywhere because alignment is 100%. All the regions are conserved. This was the first point that you are supposed to understand. Moving forward to that, which one should we choose? Generally, as you are seeing, it is hard to find GC rich content region. So what will you do? Press Ctrl and F, write here G, as I have written here G, and now G regions are highlighted. Now you can see that in this region there are more G, in this region there are more G. This is the region which do not have G. So this is how you are having an idea by visualizing it manually. So we are supposed to select or choose the forward and reverse primer. How to choose the forward primer? Forward primer is chosen from this side, this area, and the reverse primer we will use from this area to the reverse direction. So can you observe that this is the area which is having more G content? So it will be more appropriate to choose this area as compared to this one. So in this very similar way, choosing the G content, like this is the reverse stand, and here we have more G or C content than this one. Alright, so I have choose forward and reverse primer this like this. Alright, so the next step is about, here is one more important point. You may have the diverse gene and you may not find the 100% alignment. For example, you may find some conserved region here, some are in the middle and some are in the beginning, but not the consistent consensus conserved region. Alright, so in that case, the one reason might be that you have not choose the direct or correct orientation. You may have selected plus minus sequence as well. You should avoid that. In another case, if that's happened, so then you must choose the sequence from the first or the last, because there will be a gap of nucleotide and it will be good for your primer designing. So moving forward, as we have found our reverse and forward primer, I'll Control C, copy this forward primer and move on to the next step, which is the last step of Oligocalculator. So I will paste here and then we'll calculate. So what you can see, length is 19. Let's see that either we have choose this primer correct or not. Length is 19 and initially we decided length should be 18 to 25, means it is satisfying the criteria. Percentage of GC content should be between 40 to 60. Here we have percentage GC content 58, it means it is quite good. Melting temperature should be between 55 to 65, and here we have melting temperature 58 and ideally it should be 60. It is quite feasible, so I think this is a good primer to go for. So this one sequence is selected on the basis of primer specificity. What we are supposed to do now, we will again check the other sequence of reverse primer and we'll match the criteria with our primer specificity. Control C. Again come back to the JustBio Oligocalculator, paste over here and then calculate. The important point is that rest of the criteria can vary, as the length was 19 and this reverse sequence has 24. It does not matter. What matters the most is similar melting temperature, and we have the similar melting temperature of 58 degrees Celsius. It means both of our primer are feasible according to our primer specificity and they are correctly designed. This is how you are supposed to design your primer. So okay, as I have written here, the point of trimming. So what is the role of trimming? Trimming basically helps you out in maintaining or optimizing the temperature. How? Suppose I remove this C and then again I calculate, the temperature has decreased. In the similar way, if you have less number of sequences like this, if I add all these 4 sequences from here and I'll see the calculate the temperature, it has reduced. So you can have a long nucleotide of some more, it is 16, we have a range of 18 to 25. You can add some more nucleotides. After the addition of more nucleotides from the sequence, previous sequence, you will calculate the temperature has been optimized. So trimming helps you in optimizing the parameters. This is the role of trimming. Another important point is here it is written putative primers. Until the steps of grouping, the primers are putative. It means it is not confirmed. Primers are basically confirmed only when you go through the steps of JustBio. Like in this case, here 55 is the appropriate temperature. Sequence GC content is between the range. It means it is now quite feasible for you to use it. Instead of, now you cannot say that this sequence is a putative sequence. This is no more putative sequence. This is your design primer. The video ends here. If you have a time to see one more thing, there is an important point about JustBio. Some people face certain difficulty in lock-in. If you have used one Gmail for once ever in your life, do not use that updated or reused by the JustBio authorities. So what you can do is register with a new account at least, or with an email of a person who reside nearby to you who can give you the password, but that Gmail should not be used before. Otherwise, whatever you do, forgot password, new account, whatsoever what you do, it is not going to help you in any case. Rest for the whole video. If you have any query, you can comment below in the comment section. I'll help you out to the best of mine. Thank you very much.